So welcome everyone to another edition of our Vision and Language Seminar. Today I have the honor to introduce Dr. Muhao Chen. He is a researcher at University of Southern California, ISI. Prior to USC, he was a postdoc fellow at UPenn, hosted by Dan Roth. He received his PhD degree from UCLA Computer Science Department in 2019. His research focuses on data-driven machine learning approaches for processing structured data and knowledge acquisition from unstructured data. Particularly, he's interested in developing knowledge-aware learning systems with generalizability and requiring minimal supervision, and with concrete applications to natural language understanding, knowledge-based construction, computational biology, and medicine. He has published over 40 papers in leading AI, NLP, and computational biomedical venues, and he has won a Best Paper Student Award at ACM-DCB and a Best Paper Award nomination at CON. So without further delay, I yield to Dr. Chen.
Thanks a lot for the introduction, and thanks for having me here. Yeah, actually, this is Muhao. I put my affiliation as both CS department and the ISI because I'm going to join the CS department as an assistant research professor in this July, but so far I'm still a researcher at here, so at ISI. Yeah, so this talk titled Understanding Event Processes in Natural Language, it's actually going to be a part of a tutorial I'm organizing at ACL. So the tutorial is focusing on event-centric natural language understanding, where we are going to focus on a lot of the problems all the way from extraction to prediction, kind of downstream knowledge acquisition, and different applications of event understanding in natural language processing and also computer vision. But this is actually one part of the talk which is focusing on understanding the evolution of events in natural language. So I would say this is going to be a talk which is more introductory than heavily technical. Yeah. So starting from the high level perspective, I would say we are going to discuss a lot about how to model and predict the evolution of events, and how do we infer the intentions and the consequences of event processes, and how should knowledge about event processes to help downstream applications of natural language understanding and also computer vision. Yeah, so let's get the talk started. So the first message I'm going to bring out in this talk is that human language always communicates about the progress of events. For example, imagine that when we talk about earning a PhD, we can actually talk about lots of events in a sequence, starting from you need to fulfill the course requirement to pass qualification exams, so on and so forth, until we defend the dissertation, right? So all those examples, all those events in a sequence, which are towards the goal of earning a PhD. Yeah. So definitely understanding natural language by the machine, we would also require the machine to understand the evolving events. Then towards this mission, there's this first fundamental question. So what is an event? So I would say there are lots of different definitions by psychologists, linguistics, and also computer scientists. So everybody is kind of thinking about a slightly different definition. But there's one definition which is close to consensus. That is to say, an event is always an action or a series of action which happen at a specific location within a period of time. And more importantly, it will change the state of some objects. So for example, let's consider Jeff shaved my hair yesterday at home. This is an event. So there's an action which is shaved and it affects the state of object, which is actually my hair. My hair is going to be shorter, right? Also, we may mention the time yesterday and the location at home. Although those modifiers, temporal and location modifiers, are sometimes optional, but what is really important is the action and the object that is affected by the action. Yeah. Then how to recognize an event in the text. So I would say there are already plenty of work which has been done to extract event in text. That's actually not going to be the focus of this part of the talk, but I would just say that there are two lines of research. There are supervisor methods, which is kind of like you do name entity recognition. So you have annotated documents like ACE, RED, and the ERE, and also use those annotated documents to train either a BioSTM-CIF or a sequence to structure generator. And there's another line of research which is more like unsupervised. So we just do semantic role labeling, identifying the trigger and also the arguments of the event. Yeah. So these are some typical methods to identify events in text. However, to understand events, I would say only extracting them is far from enough. This is because events are not just simple standalone predicates. They often form processes. For example, we know that in the process of earning a PhD, fulfilling the course requirements is something happens before you pass the qualification exams. And after that, you can do dissertation proposal. Right? That's actually a process. And events are also described in different granularities, which means that a coarse-grained events, for example, publishing a paper, this would involve a more fine-grained process of events, starting from writing the paper, passing peer review, and you present the paper at the conference. Right? And what's more complicated is that events are often directed by specific intents or central goals. Actually, we can see that all the events at here, they are directed by the same central goal of earning a PhD degree. Yeah. So particularly, I would say those processes or complex structures and the intentions behind events are something which are not directly extractable from text. So they often involve some efforts of prediction. Right. So in this talk, we will focus on this kind of data structure called the event process, which is modeled as a set of partially ordered events that is centered around the same protagonist. For example, at here we have this protagonist, the student, which is performing a series of events of earning a PhD, something like you fulfill the course requirements until you file the dissertation. And there are some fundamental problems regarding event process understanding. We may expect the system to perform event process completion, which concerns the prediction of what happens next. And the intention prediction, which concerns some problems about whether the machine would understand that the process of digging a hole, putting some seeds in the hole, then fulfill the hole with soil is a process for the goal of planting a plant. Right? And there are also membership prediction, which is the question about what are the essential steps of buying a car, and the salience prediction. Does the machine understand that in terms of earning a PhD, defending the dissertation is much more important than doing an internship? So those are some fundamental problems we're thinking about. And on the application side, actually understanding event processes and making reasonable prediction, it's also essential to many real-world language understanding tasks. For example, take an example in narrative prediction. So suppose we are trying to predict what should be the continuation of the story about a boy is visiting his aunt. Then he was happy at the beginning, but when his aunt turned attention to her own daughters, and the boy got jealous and angry and took a bite at her at his sister. Then so to infer the meaningful continuation, one easy way to do this is to keep track of the evolution of the events in the story, so that we know getting jealous and getting angry and took a bite at someone, this is more likely to be followed by getting scolded rather than getting a cookie as a reward. Right? And in the same context, understanding event processes is sometimes also important in machine comprehension, such that we may often see cases where understanding a piece of biological article, it is centered around understanding a biological process. So in the rest of the talk, I will split the technical content into 4 parts. I will focus on recent advances in solving the problem of event process completion, then also event intention prediction problem. And also I will discuss how those knowledge about event process help downstream applications of natural language understanding and a little bit of computer vision. And also I will discuss about a few open research directions in this area. So let's first look at the problem of event process completion. So there are two different definitions of event process completion. One is that given a partially complete event process, a system is required to predict the missing steps, or perhaps more often, we require the system to predict the future steps. The other definition, which is more challenging, that is to say, given a coarse-grained event as an objective, the system tries to predict the entire process of this objective from scratch. So for the first problem definition, one of the earliest attempts to automatically completing the event process is published by Chambers and Jorovsky in 2008. So in this ACO paper, this pioneering work seeks to conduct unsupervised event process completion based on corpus statistics. So the principle is that given a large corpus, in this work, they used 11 years of gigawatt corpus. There's a system which captures the co-occurrence of events based on their PMI. Then the next forthcoming event will be predicted as the event which maximizes the accumulated PMI through the process. Such that here we have this example. So their system is able to give this kind of prediction. Suppose we know that the beginning of the process is pleaded, admitted, and convicted. It is more likely to be followed by sentenced, paroled, and fired, something like that. And in the same work, the authors show that by performing this kind of event process completion, it is able to lead to as much as 36% of improvement on the New York Times narrative clause test over the best baseline during that time. Okay. So there are several significant works which follows Chambers and Jorovsky's design. One is by Radinsky and Horvitz, published in 2013. So in this work, they extend the unsupervised learning of event chains to a cross-document scenario. So that is to say, they actually used a 6-month span of New York Times articles. And the system first identifies topically cohesive documents along a period of time. Then the system will form, from the titles of those documents, the system will train a maximal entropy-based model, which captures the co-occurrence of events in a chain, purely based on the titles of articles. Then this technology is applied to predict possible forthcoming news along the timeline. So such that it can predict the likelihood of cholera rising after a drought followed by the storms in Angola to be high. So the aforementioned line of research focuses on predicting forthcoming events after a part of an event process. Then a more challenging research question would be, can we induce a new process for a goal without seeing a part of it? So that is to say, given the objective, let's say buying a house, can we let the machine automatically induce all of its steps without knowing any of them beforehand? So this is actually a hard problem that is recently attempted in a EMLP paper of us published in last year. So the general idea is actually very straightforward. So basically, we try to leverage the analogous property of events and transfer the knowledge about some event processes we already know to some processes we don't know. Actually, this mimics how humans understand processes that we are not familiar with. For example, assume that one has never bought a house. Therefore, one may not know the detailed process of buying a house. But one may already know the process of buying a car and also renting a house. So intuitively, those relevant processes should contain some relevant steps. And based on such relevant steps, we may guess the necessary steps of buying a house, even we do not have the real experience of buying a house. So this is the overall framework of our system. So there are actually 3 steps. So in the first step, given a goal, say buying a house, the system will first find a group of relevant processes that are either sharing the same predicate or the same argument with the central goal, which means that our system will find lots of processes about buying something and also a lot of processes about some actions that is taken upon a house. Right? Then based on those reference processes, the system will try to predict the event sequence of the objective based on the content of them. Then to do so, the second step applies an event conceptualization technique, which acquires a more abstract representation of each of those processes. You can think about that as like we are doing a semantic abstraction of all of those processes based on hypername detection. Right? Then based on the more abstract representations of all those event processes, we are performing a probabilistic graph union of all of those processes and identify a common pattern. Then based on the common pattern, we do a further step of event instantiation. So from that, we are going to get the process of buying a house. I'm actually not going to spend too much talking about the details of the techniques, but here are some interesting results. We can see that based on the event processes in WikiHow, we can see that the system is able to achieve much better performance than the sequence to sequence generation method. And also it's about half of the human performance so far. And based on example, we can see that, okay, given the central goal of treating the pain, we can actually generate a process of starting from identifying the symptom, seeing the doctor and recognizing the symptom and taking some supplements. Right? But at the same time, I want to say this is actually a pretty hard problem, generating a new event process from scratch. And there's still much gap between the best machine performance and the human performance. So we have the resources available on the Qualcomm website. So interested audience are welcome to play with the release dataset that is available at here. Yeah. So these are a little bit about event process completion. I'm going to talk a little bit about event intention prediction in the next section. But before that, I want to see if there are some questions by the audience about event process completion. Okay, thanks. So let's continue for the event process intention prediction part. So the motivation of this prediction problem is that people can easily anticipate the intents and the possible reactions of participants in an event. So for example, when we see this kind of event about the person X cooks Thanksgiving dinner, we can easily understand that the intention should be something like maybe person X is trying to impress their family, and the reaction could be that the person X would feel tired, but the family will be impressed. Right? So similar to human behavior, we would also expect a common sense aware system to perform such inference. So this problem is first attempted in this work, Event to Mind, which is published by people from UW in this ACL 2018 paper. So in this event to mind system, this is developed based on a large corpus, large cross-sourced corpus, which contains around 25,000 events, and also free-form descriptions of their intentions and the reactions. So the model is trained on the corpus to perform a sequence to n-gram generation, which shows pretty good generalization to give free-form intention prediction of events. For example, given the event, person X cooks steak, it is able to predict that the intention should be something like to kill their hunger, to make the dinner for their family, and also to eat the steak. And the resource of the event to mind has later fostered some important works for common sense inference. I think some of you have already heard about the atomic and the comet. Those are actually built upon the resource, which is first released in this event to mind work. And that's about intention prediction for single events. But naturally, we can say that the intention prediction should also apply to event processes as well. And this is actually suggested by cognitive studies, which tells us that a process of events is always directed by a specific central goal or the intention of the performer. for the event process. So for example, when we see this kind of process, starting from digging a hole, proceeding the hole and fill the hole with soil and water the soil, we humans can easily understand this is a process which is directed by the central goal of planting a plant. And similarly, when we see this process of making a dough, add toppings to the dough, preheat the oven, and also baking the dough, this is likely to be the process of cooking pizza. Right. So actually, we know that humans can always understand the event process by hypothesizing the objectives the process aims for, and also the ultimate consequence the process seeks to accomplish. So naturally, we would also expect a common sense aware machine to perform such inference. So in this 2020 work published in last year's corner, we actually got best paper nomination for this work. So in that work, we actually proposed a new cognitively motivated semantic typing task for event process, which aims for infer what should be the overall action a process seeks to take, and what should be the type of object that is affected by the process. And to facilitate the research on this problem, we also contribute with a large data set of typed event processes, as well as effective method to address the problem based on the indirect supervision. So the data set we extract is based on WikiHow, which is a large community website containing professionally edited guideline articles, which basically tells us what is the process of how to, let's say, cook a steak or something like that. Yeah. And the data set comes with more than 60,000 event processes, and each of which comes with free-form labels of action and object types. And it is noteworthy that this data set comes with a pretty challenging typing system, such that we do see this is an ultra diverse vocabulary of more than 1,000 action types and more than 10,000 object types. And we also know that around 85% of the labels are actually few-shot labels, and a half of them are actually one-shot labels. And at the same time, we also notice that in around 90% of the processes, the labels do not even appear in the process, the content of the process, which means that simply applying an extractive method is going to easily fall short on this problem. So to solve this non-trivial typing problem, we propose a practical form of indirect supervision based on gloss knowledge. That is to say, instead of predicting the type labels based on event process content, we find it to be much easier to predict the correct wordnet gloss, which defines the type label. This is due to that the sense definition of the label itself in the wordnet is actually semantically much richer than a single label. So therefore, it is actually much easier to seize on the association between a process gloss pair rather than a process and a single label. And also at the same time, the gloss in the wordnet, which defines the label, also provides useful side information to jumpstart the representations of few-shot labels and zero-shot labels that do not even appear in training. So this is the overall architecture of this framework. In training, we use a Roberta language model to encode the sequence of events in a process. And we use the same language model to encode the gloss of the label. And the training process is going to select the right gloss in learning to rank objective. So this is kind of similar to we train a natural language inference model. But at the same time, we also incorporate a word sense disambiguation model because sometimes the label, for example, you can think about if the label is make or get, it can be polysemous. So we also incorporate a pre-trained word sense disambiguation model to select the right gloss if the label is actually polysemous. And during inference, it's also learning to rank. So this is kind of straightforward. And the results that here show some promising performance by this kind of indirect supervision method, which leads to 3.4 to 4-folds of MR improvement over regular Roberta-based sequence to label generator. So that is actually, the baseline is kind of similar to the event to mind work from the UDA group. And specifically, we do see that the indirect supervision is from gloss knowledge is kind of very helpful. It actually brings the most improvement, which is around 2.9 to 3.3 folds of MRI improvement. And we also see that joint training also leads to notable improvement, although seems like the sense selection technique based on word sense disambiguation is leading to lesser improvement, which is actually due to the fact that predominant senses is often representative enough to jumpstart the representation of a label. So here we also provide a case study which shows how the system perform process typing on the news domain. For example, here is this process which is from Kairos. I think Yezhou probably knows this process. So starting from making explosive materials, obtaining container, obtaining shrapnel, and also installing a trigger. The model actually understands that this is a process which is related to assembling a grenade or assembling a blaster, even though we know that this process is not possible to appear in WikiHow. Right? And that here, I mark some labels as blue. So those blue labels are actually the labels which appear less than 10 times in the data set, which actually also tell us that when we incorporate this kind of gloss-based indirect supervision, it's actually leading to fairer prediction. Yeah. And we also have this web demonstration of this system. I probably can take some time to show it. So you can see the web demo page, right? Yeah, so this is actually a pretty simple, yes. Yeah, this is actually a pretty simple web demo. We can see that given something like read papers, attend conferences, and go to seminars and write a thesis is kind of relevant to getting a doctorate. And there are some examples here, but we may also type something on the fly. For example, let's use the example from the beginning. So making a dough, add toppings, preheat the oven, and bake the dough. This is kind of close to bake focaccia, something like that. Yeah. Yeah. Anyway, this web demo is actually available on the Qualcomm group. You can easily find it in the publication page. But I also share the slides with you if anyone's interested. Yeah. Oh, and that's about intention prediction of event processes. So any questions from the audience about this part?
There is a question in the chat.
Oh, actually, I cannot see questions from the chat one.
Okay,
so presenter view.
Them out. So Varun asks, how long can these processes be?
Oh, that's a good question. So you mean the process of the typing task, right? So in the data set, the process length starts from 1 to, I think the longest is probably 13, but there's actually no limit of the process. We actually do find that longer processes are easier to type because it's reasonable because a longer process provides more contextual information of this objective. Yeah. And shorter ones are typically harder to type. That's actually a part of case study in this paper. Yeah, but that's a great question. Thanks. Any other questions?
Is there a fixed set of vocabulary for the types, or are the types also like novel types can be generated?
Okay, that's a good question. So we are limiting the vocabulary of the type system in as everything, all verbs and all verbs for actions and all nouns for objects in the WordNet. So it's actually a pretty large vocabulary already, but it's close to open domain, but it's not purely open domain if you think WordNet is kind of still a closed word.
Yeah. So is there like a study of how novel the new type system is coming up? Some like adding a new verb and combining a new verb and a new noun, which is not present in your training set.
Oh, that's a good question. So based on what we know from this case study, you can see that lots of those blue ones that here are those which really happen in training or even never happen in training. We actually do observe that. So when we use this kind of gloss knowledge to jumpstart label representation, it's actually leading to less biased prediction, which means that when the objective is kind of something which is far from the frequent stuff you will see, such as make and get, the model can also predict them. For example, you can imagine something like a negotiation or like, I don't know, detonate is something which almost never appear in training.
Yeah, but like so these verbs can appear with the noun in the steps of the part of the processes, right? Is there like an overlap? Means does the blues
Oh,
color
oh, oh.
they
I
have?
see. I see what you mean. So at here, I already said that actually most of the cases, the label actually do not appear in the process body.
Okay.
For example, you can see something like still this example. You see assembling a grenade or something, but there's actually no grenade and no assemble in this in this body. That's actually the majority case.
Thank you.
That's actually why this task is kind of challenging. But we just had this first work. We are still trying to expand in this work towards some further directions. But this is actually a direction with lots of open spaces. Yeah.
Yeah, and like a final follow-up to it, like is there a study like of like vector space distance between the predictions and the verbs present? Like say the robot, if you take the robot embeddings of the verbs present in your input and the generated output and find the distance between them to see like similar to the word to vec kind of analysis, right? Like, okay, detonate might be close to shrapnel in the vector space. That's why it might be bringing that verb up.
That's a good question. That's actually relevant to one open research direction I'm going to talk about at the end.
Okay.
So why don't we save this answer to later?
Sure.
Okay. Yeah, thanks. That's really a great question. Yeah. Okay, yeah, let's probably continue. So the next part is about when we have those understanding of event process, or we have those explicit representations of event processes, how do we apply them into some real natural language understanding and also a little bit of computer vision tasks? So since event process model, it models the plausible evolution progress of events in a context, then they can be naturally used to improve the consistency of narrative prediction. So a narrative prediction task often requires a system to predict the possible continuation of a piece of narration. So for example, again, this is the instance we already saw from the beginning, which is actually from the rock story narrative close test. So this is about, this boy visits his aunt and he was happy at the beginning, but later when the boy's aunt turned her attention to his sister, then the boy got jealous and got angry and took a bite at the sister's hand. Then what should be the reasonable continuation? So actually in this paper by Snegda, who is now assistant professor in UNC, they actually trained a language model which captures 3 types of sequential features. So there's event sequences in 20 years of New York Times. There's sentiment trajectory, there's also topical consistency, but actually in this study, they do show that the event sequence is actually a much more important factor than the other factors. such that with this event sequence feature alone, it's already performing very promisingly. And also, we do see that modeling event processes is kind of important for machine reading comprehension as well. For example, in this task, a system is required to answer some questions that are relevant to a given article. So this example is from this award-winning paper by, I think by Vivek Srikumar and some other people from Stanford. So this is actually MFC 2014 best paper. So at here, how to understand the biological process described by this scientific literature, the proposed method actually also extracts the events and also event-event relations in the biological process. Then the question answering is conducted as matching the events in the question to candidate answers within the extracted process. And of course, they also show that this is actually a very effective method in terms of understanding machine comprehension in the scientific domain. So another key application is actually in the computer vision field. This is a task which is called video segmentation. So this task aims at understanding the content of a video and splitting it into different relatively independent segments. For example, when we have a video talking about making a pancake, this may be split into segments talking about the background and also different steps of the cooking. Right? And in two recent works by Zhukov and also Daniel Fried, this problem is done by first extracting narrations from the video, then aligning the narration to different steps in a WikiHow event process. So in this way, different steps in a WikiHow process naturally serve as anchors for the video segments. Yeah. This is actually how event processes helps video segmentation. And in the same area, there are also some works focusing on directly recognizing and modeling the event processes in videos. For example, there's one recent work by our collaborators from Columbia University. They propose to use hyperbolic embeddings to capture the event evolution sequences in videos. So here, because the same kind of event process may branch into different possible paths of evolution, so this naturally forms a hierarchies that are suitable to be captured by the hyperbolic geometry. This is actually a very new work which has just been announced on arXiv 2 months ago. But I'm actually not sure where they submitted this paper to. But that's actually a pretty nice work, I think. Yeah, actually there are lots of other applications that are potentially benefitable by event processes. So any questions before I jump to open research directions?
So Ketli had a question about the previous demo site. So on the CC, are you holding the input users give and adding that to the model so it can learn a new vocab?
Can you repeat the question, Bill?
It's for about the demo, like
yes.
on that site, are you holding the input the users are giving and adding training that to the model so that it can learn a new vocab?
No. Actually, on that demo, there are some examples, but you can actually type in some sequences of events on the fly. It's actually not limited to specific vocabularies. The input is actually a purely open domain. You just need to use an add to separate between different steps.
No, like, are you taking a query log and to gather new samples so that you can learn a new vocab about the inputs, or about if you have like outputs also?
Oh, that's a good question. We are not doing human in the loop, something like active learning in this stage, but that's actually a good suggestion. Yeah. So far, we are not doing this. Yeah. That's still a very simple demo in this current stage. Yeah, but we are developing something new. Yeah.
Are there any questions regarding the event stream, event process in the downstream part? Chat, you can feel free to unmute and ask. Okay, looks like you can go ahead. Thank you.
Okay, thanks. Yeah, so I just have a few more slides about open research directions, but we can definitely have lots of discussions after that. So yeah, some open directions we are specifically thinking about in our mind is one is the salience or essentiality detection in event processes. So at here we know that okay, we just covered the problem of intention prediction, but here one unresolved problem is that events in the same process is actually not equally important with regard to the central goal. For example, let's go back to the process of planting a plant. So at here, if I remove water the soil and I just preserve digging a hole, put seeds in the hole and fill the hole with soil, we can still tell that this is a process of planting a plant, right? But if we remove put seeds in by just observing digging a hole, fulfilling the hole with soil, and water the soil, it's hard to tell what the process means, whether it's planting something or whether it's burying something, and we don't know what is the something that we are burying, right? So this is actually kind of relevant to the previous question we skipped. So at here, some clue we have is that the essential events may contain some arguments which is close to the argument in the central goal. Yeah, but that's actually not the only important step of reasoning at here, because we also need to consider the precondition relations between different steps, something like that. Yeah, but okay, so in the same context, the question for the machine would also be, does the machine understand that defending dissertation is essential towards any PhD, but doing a THF is less important, and doing an internship is totally optional, right? And does the machine, does the machine has the ability to automatically identify those kind of salient or essential events? And furthermore, will this kind of knowledge help tasks like abstractive summarization? This is a kind of meaningful open research direction. We are actually doing some investigation currently among our team. And there's another open problem, which is about reasoning of the ordering of events. Consider that events in a process may not be necessarily described in a document in the same order. Then in that case, how to identify the correct ordering of member events in a process from a document? This is also an unresolved challenge. So for this problem, there are already two recent benchmarks, test beds, without very effective solutions so far. Actually, both of them are published in this past EMLP. One is actually also from our side. That's the TORC dataset, which is actually a reading comprehension dataset about temporal ordering of events, which is crowdsource based. And there's another dataset by CCB from UPenn. That's actually a WikiHow based dataset, which is about event ordering and also something more than event ordering. Yeah. And in the same context, there is also another open problem about event extraction. So there are also some special cases of event extraction that current unsupervised methods are not able to identify. For example, at the beginning, I mentioned a little bit about using semantic rule labeling to perform event extraction, which means that the SIO will identify the trigger, which is a verb, and also arguments of event. But at here, this is not a solution to identify nominal events like some tournaments or some war or some matches. So for that problem, the question will be, can we actually detect those nominal events based on word senses or maybe entity descriptions, something like that? And there are also some imaginary events. For example, Jeff shaved his, planned to shave his hair yesterday, but he was too busy to do that. So that's actually some kind of event which was planned but not happened. So clearly this does not have a specific location and time property, right? So I kind of discussed this problem with Professor Martha Parma from Colorado. But actually what she told me is that this is a kind of a Pandora's box nobody has tried to open yet. Yeah. And at the same time, there are some cases where we do see a verb in the text, but that's actually not an event trigger. For example, this example, Jeff's haircut looks good and fresh air smells good. So those are the cases where we see a verb, but this verb do not cause a change to the specific object. So regardless of whether I look or not, or whether I smell or not, the air is always fresh and the haircut is always looking good. Right? So those are the cases where we see verbs, but that's not event. And there are some more tasks we are interested in, which potentially are important urban research directions. So one is that we just mentioned that using event processes, this could help improving narrative prediction. So then to go one step further, can we use this kind of event process knowledge to improve the consistency of utterance generation or utterance retrieval for chatbots? This is another meaningful direction. And in the same context, we also have this, that's actually a collaboration with UCLA Medical School. So can we use this kind of event process understanding knowledge to help the machine understand clinical event processes, such that we may think about developing reliable systems to help machines perform those important clinical tasks, such as diagnostic prediction and disease phenotype prediction. So I think those are very important directions. And particularly for this direction, I think transfer learning and structure prediction, they can be particularly important because in this area, naturally there will be lacking of data due to privacy issues. And also there will be dependencies between different labels of phenotypes and disease labels. Right? And here I also want to advertise a little bit that I'm organizing this tutorial at ACL. So the title is about event-centric natural language understanding. So we have those, large group of instructors. We have Hongming from UPenn, Chang previously from AI2, but now is at Amazon. We have Manling and Henji from UIUC, and also Kathleen McCall from Columbia, and also Dan Ross from UPenn. So we are covering 6 key directions under this umbrella. We'll talk about all the way starting from event extraction, event relation extraction, and I'm talking about event process understanding. And there will also be eventuality knowledge acquisition in the umbrella of common sense understanding, and also event-centric natural language generation by Kathleen, and also important future directions. We actually already had one version of the tutorial at AAA, but the ACO one is actually going to be much more updated. Yeah. So these are some important references. So the bold-faced ones are those from our group. And I will share the slides to the host after the talk in case anyone is interested. Yeah, thanks. Happy to take questions.
Thank you, Muhao.
Thanks.
Let's see if we have any questions from the audience. Actually, I have a question. So when the community is dealing with event extraction, it seems you guys are mainly defining, although the community is mainly defining a sequence of events having a kind of linear relationship. Have anyone considered, because for example, in robotics and even in video understanding, there is this repetitive patterns happening. For example, if you want to organize, let's say, a table, it's actually a loop that detects one object, approach, grasp it, organize it. Then you go back to the next loop, check if the whole table is organized. If not, then detect next object, organize it, and then initiate the next round of the process. So do you have any insight along that line, or whether this could be an interesting direction to go for event extraction from either natural language text or from the video data?
Yeah, that's actually a great question. So interestingly, you asked this question. Yeah, I want to answer this question from two perspectives. So first of all, event modeling or people doing this kind of event language modeling. Over there are considerations of sequences at the beginning because sequence is easy to model. You can just extract everything from the document in the same context and kind of perform some temporal reasoning. So this is actually the most straightforward way to model events as a chain. Although a more comprehensive way to consider this is organizing events from into hierarchies. You can think about some coarse-grained events may contain memberships between itself and more fine-grained processes or something like that. So there are also lots of considerations through that direction. And we do have works also jointly extracting temporal relations with membership relations. That's actually also one EMLP paper I didn't mention in this talk from our side. But in terms of recurring question, in natural language, it's interesting. I personally don't know anyone in the natural language field who has specifically considered this. Maybe I missed something, but in the same time, I myself has a paper which is about future event prediction on temporal knowledge graphs. And over there, I'm actually basically dealing with this kind of a recurring event prediction. You can think about when we predict the NBA championship of the following year. It could be the team which has already won the championship before. Right? So in that paper, I was using this kind of the copy generation mechanism, the same thing you see from abstractive summarization. That's actually a AAA paper I published in this year. But interestingly, yeah, maybe in the video, in the vision domain, people have already considered this, but I do think that's something that natural language people has so far overlooked.
I see. Yeah, I can understand probably.
Wait. Actually, I think I'm wrong. So actually, there's one work about temporal common sense understanding from Dan Ross group. So over there, actually, that's a paper by Banjo. So over there, actually, they are dealing with 3 different kinds of temporal common sense. There's a typical time, which is about, for example, do you know that you eat breakfast every morning, and also typical time duration, which is something like when you PhD several years, not several months, not lifelong time. But there's also typical time frequency understanding. So that's actually relevant to recurrence events. Do you know that you have breakfast every day almost, but when talking about people going to church, it's about like once a week or something like that. Yeah, sorry.
Muhao, I had a question. Hi, this is Chitta. So in your sequence, where does the Propera data set by Allen AI comes in? The Propera, and they have, I think, some more papers. Do you know what I'm talking about?
You mean the...
You mention it, Propera? It's like the biological kind of thing, a bio.
Oh, this you mean this machine comprehension data? You mean it, you mean the example at here?
Yes. Is that the Propera? No, that's not Propera.
So in Propera, you have to actually figure out where the object means the objects are getting created or destroyed during the event sequence happens in a process.
I just wanted to see where it fits in your framework. Let me put it link, give you the link.
That's actually not a work by our team. That's actually a work from Stanford, but
no, not by your team. It's the Allen AI.
Okay, this is actually a work by Stanford, so I'm actually not familiar with the AI work actually.
So there it's about, I think, a complementary task. It's like here it's more focused on the events, but there it's more about the objects and what's happening to them. It's like when the event happens.
It's reasoning about events. Like you have the events kind of described in the text, and then it asks you to find at different time points what is where. So let me give you an example.
I think that work was published around 2018. In this one that you mentioned is 2014. I think that work might be based on this.
And there's, I think, a follow-up paper, more recent paper on this. You can No, because you're doing tutorials, so that's why I asked. So
Oh,
you
yeah,
have a look at it.
That's probably something more updated. I should talk about that instead. But yeah, that's a what 2018 paper by EIT.
Yeah.
Okay. Yeah.
But I think there's a follow-up paper in 2020 also. I don't know what I just cannot remember the title.
Okay.
Yeah.
And it's about machine reading comprehension in the scientific domain.
Right. And it's about events and what happens. Like the events are of two kinds. Is something might be introduced, something might vanish, and what is if they? So the questions are about if the events or if the objects are exist, and if they exist, where they exist. So if you click on that link, you can see there's a table that you have to fill up.
Oh, you send a link across. I actually cannot see it while I'm presenting the slides, but yeah, I should.
I think you can exit the presenting mode, and now you should be able to see the
Okay.
chat.
Okay. Yeah. Sure.
So if you go down that page, you'll see a picture where there are statements, and then there's a table that needs to be filled.
Prepare. Okay.
But your presentation was wonderful. Thank you. I mean,
Okay. Thanks.
Get to see all of these things together.
Yeah. Yeah. That's actually a great suggestion. So because we are still 5 months away from the tutorial at ASU, so I should basically get it more updated. Yeah.
And another question to people these days ask is like, how are all these benchmarks affected with the large language models? So do they make it easier on some tasks? Which tasks if they make it easier? Where these days everybody's asking that question.
Okay. Yeah. So yeah, there are lots of tasks that here. So what I know from Chang is that for the temporal ordering data set, because I know they are studying some follow-ups, which is in submission. So over there, do you see that, for example, T5 is probably performing much better than something like Roberta-based? That's actually what they have discovered in terms of event temporal ordering.
Right.
That task. And for intention prediction, we are still working on the salience part so far. But for intention prediction, actually, we haven't tried something like T5, but that's definitely something we will think about in the next loop. Yeah.
So also these guys, a different LNAI group, they have these papers on the common sense about events, like if this event happened, this will happen, or the predictions.
Okay, I see. So you're talking about this strengthener and weakener paper by Yejing.
No.
Atomic.
You remember, right? What is the paper before Comet, which has the knowledge about it?
Atomic.
Atomic.
Yeah, Atomic is the resource, is the AAA one, which is the resource paper of the Comet.
Atomic is also from Yejing's group. So
yeah, Yejin Choi, right. Sorry.
Yeah.
Yejin. Yeah, you mentioned that. Okay.
Yeah, but actually they have some follow-ups about whether some precondition, whether some conditions of some conditions would strengthen or weakening the likelihood of some events.
Right.
Yeah, that's actually a different work. But actually, we also had some recent work about this kind of precondition. So whether some precondition would completely nullify the possibility of some events in terms of natural language inference. Yeah.
So Muhao, I actually have one more question. Could be naive. If you input into a process such as like started your PhD, attempt qualification, and then let's say you failed, then you reattempt the qualification. You see, I mean, from a robotics point of view, we see it as like a program. So how would the current model take care of that? Or I see you are treating it as input and then categorize it into one of the so-called general events you are denotating as. But what if, let's say, someone qualification failed, and then after multiple times he is basically give up, right? So is still pursuing a doctorate, and you see what I mean?
yeah, I know. I think that's kind of also relevant to this essentiality and the salience problem. So basically, you know, when a model actually knows, okay, there are some steps which are essential, but in the process, this step is failed, then it tells us that, okay, the entire process should fail.
Okay.
Something like that. But that's actually one kind of, you know, open problem we are recently investigating. Yeah, but of course we are not reviewing it regarding this as a program, which is not that kind of reasoning stuff.
I see. Cause in recent, I'll send you a paper in I think also he is with USC. I forgot his name, but he is doing work of translating people playing video games into a program. So essentially, taking the video game recordings and then translate into a set of procedures. And these procedures are essentially pseudocode, right? You need to reach A and then get B, and then if failed, then go back to C, and then further. And ultimately, the goal is to, let's say, kill the ultimate opponent. That I don't. I mean, is there any kind of interesting aspect? Well, I can tell from my gut feeling they are relevant, but I don't know whether there are any interesting future work could be.
I think this is also kind of relevant to, you know, for example, from the IE side, first we have this schema induction. Basically, it seeks to extract, for example, there's a document talking about bombing issues and what should be the general process of you know, preparing the bomb, something like that. That's actually the Kairos example. I think you're familiar with. So over there, there's this kind of schema induction, which is also kind of relevant to script learning. But that's from the text side, I also know that John May is working on. There's something called text game, which is something like you read a textbook. No, you read a book, but this is a story which allows you to make selections, make choices. So for example, you read a part of it, then there will be a choice. There will be a question presented to you, and you will make some choice which affected the progress of the story. That's probably something which is directly relevant. It's still a game, and you make decisions, but purely based on text. That's actually in Jonathan May's team, they have some studies on that.
I see.
Yeah.
So the name I'm mentioning is Joseph Lane. He is with the USC, and one of the work he talked about, I'll send you the link either afterwards or if I find it during the talk. Let's open the room to see if there's any other questions from the audience.
Professor, I have one question. So in current existing like data sets for intention prediction task, do the label unique? So for each event, you only have one intention or you have multiple intention?
Okay, it's a good question. So for the process typing, for the intention prediction for process typing, we do not have multiple labels. But I agree that in some cases, multiple labels should be correct, but the thing is that we just extract the data from some easy to consume web resources. So over there, there's just a single label for action and a single label for object for each process.
I do think that multiple labels will be more suitable or reasonable, but I also don't think a good way if, even though we have like a multiple label intention, how can we train a model with these multiple labels?
I think when you have this annotations of multiple labels, you can just formalize this problem as a multi-label classification. So that's doable. Although still,
but in that case, you will restrict that the intentions are like finite, but so that's you will miss some chance to predict like novel intentions.
Yeah, that's true. That's true. That's true. Yeah. Although I would say, so in this context, the real challenge is about how to get the label, get multiple labels, right? Probably that's something which requires additional annotation efforts. But at the same time, I think, yeah, this process intention prediction task is also some kind of new task. There are lots of open spaces. For example, over there, you can also consider if you can use structured prediction to, let's say there are some strong dependency between action and object. You can also consider that as an additional signal. Yeah, but that's something we didn't have in the first version of our system. Yeah, but I would say that there are lots of ways to improve that. Yeah. But in general, I would say the comment is that I think event understanding is kind of a rising area for at least natural language understanding. So we do see that lots of people, after they finish up with all the works on event on entities, now they are focusing on events now. Certainly recently. But it's a good time to start on the research in this area.
Right. Thank you. Yeah, I send you the paper in the link in the chat, and they are dealing with translating called language guided, a program guided agent, and this line of work. I mean, yeah, it will be interesting to see if there's any synergies.
Okay, thanks a lot, Yezo. Yeah, I'll print it off.
Any other questions from the audience? If not, thank you so much for giving this talk, and we learned a lot from your tutorial as well as this talk. Congratulations on your new job.
Okay, yeah, thanks.
Forward to, I don't know, is ACL going to be in person or?
That's a good question. That's actually my concern. So first of all, I don't want to go to Thailand in August.
Where is ACL?
It's in Thailand. It's in Thailand.
Oh, Thailand. I see.
But it's in August, so it's super hot and wet. But at the same time, yeah. But I don't know. We don't have an answer yet.
Yeah, I think highly unlikely it will be in person.
Okay. Yeah, I also prefer online as well.
All right.
NACL, they announced that they are thinking about some kind of in-person parts, but for ACL there is still no announcement. So
yeah, for CVPR, they have already determined it's going to be virtual, but there might be a North American kind of local gathering they are planning. So that makes sense. Not necessarily everyone needs to travel, but if let's say a southwest part of all the universities, and if people want to meet and they all get vaccinated at the end of May, then that's actually not a bad idea to social and meet as well, just locally. Anyway, I don't know what will happen. We'll see.
Well, yeah, but probably we will have a real EMLP this year, I guess.
Hopefully.
Yeah. Okay. Yeah. Thanks, Yezo, for inviting.
Thank you so much.
Yeah, it's a great discussion with you.